Okay, so we're going to solve question number 11. And the question is the major product of the following of the reaction is. So we have been given one aldehyde. Okay, basically this is pivylyl aldehyde. And we have been given a alpha bromo ester along with zinc. So this is basically Reformatsky reaction. So we would think that when we have BrCH2 CO2 along with zinc. So in the intermediate state, CH2 CO2 this type of an organometallic reagent will be formed, and that would make a nucleophilic attack on the carbon, cleave the carbonyl bond, and so the intermediate product that will be formed will be having the structure as follows. Now, if this is something that you are treating with the tosic acid along with heat, then one could expect the removal of the ZNBR and then acid catalyzed liberation of or elimination of water. So that would lead to the formation of a double bond between the alpha beta carbons. Okay, and then if we treat this with nickel chloride along with NaBH4, so this is going to form basically nickel boride, which will be reducing the ene bond, and so the final product that we will get will be something like this. And if we compare, then our product will be D. That means nickel boride does not reduce the ester. Okay. And question number 13 says the most stable conformation of Y and that of Z are. So among all the options that are given over here, we have chair and twisted boat conformations given to us. So there is no doubt for Y. In the chair conformation where the tertiary butyl groups are in the equatorial position, that conformation will be the most stable one, as it is avoiding the 1,3 diaxial interaction. So obviously we have to choose between A and B. So for Z, whether the option A is correct or the option in B is correct. So we will say that in the twisted boat, as we can see, both the butyl groups are away from each other and they are avoiding any kind of 1,3 diaxial interaction. Whereas in A, if we check properly, then we can see there is a 1,3 diaxial interaction over here, and there is another 1,3 diaxial interaction over here. So the correct option would be B. Question number 14, the major product Y in the following reaction scheme is, so over here we will say the inorganic salt that would be formed, sorry, organic salt that would be formed will be the pyridinium parbromide. Okay, and this is a very good electrophilic reagent, and this basically, if you put a unsaturated compound in reaction with this, then the bromination will take place. So basically, this reagent helps to conduct electrophilic dibromination reaction across a double bond. So that way, if we think, then we can say that we have a molecule like this, and that when treated with leads to the formation of the bromonium ion intermediate, something like that. And then if we think of attack of Br minus ion at either of these centers, okay, so basically this will be anti-addition, right? So the products that will be formed will have the following stereochemistry. And if we rotate the CC bond over here, then we will say the compound formed is going to be having the following structure. Okay, so option B over here is going to be correct. Okay, so we have basically over here some electrocyclic reaction being given to us. So this is a 2 pi electron system and should be undergoing con rotatory. Okay, so we can think this bond going here and that coming over here. So the next molecule that we can think to be formed will be having the following structure. If we rearrange this molecule, okay, in the following manner, and then think that this is undergoing again heat reaction on the influence of heat. So this is again a 6 pi electron system. Okay, and one should think now that this will be undergoing this rotatory. Okay, So basically this will be going up and this will be going down. Okay, so if you're having this up and this as down, then that should be the molecule formed, and our answer will be over here D.